Okay, first question then, a probability question, one with lots of unions, intersections, givens, and we said before that the line over the A here meant the same as in the notation we had used, a dash there after the A, so that meant the same thing. What strategies did people use to get started in this first question? What strategy did you use to get started in this first question? What might be a good way forward? Venn diagram, yeah, if you've got unions and intersections and things, a Venn diagram would be quite good. So, if we start question 1 and draw the Venn diagram, we've got an A and we've got a B. So this is for question 1. We know A is a third, so inside A, we don't know exactly where at the moment, we're going to have a probability of a third. Inside B, we're going to have probability of 2/5, we don't know exactly where yet. And we've got this other probability here, which we can't put in the Venn diagram straight away. And that's this probability, and I'll move it up the board in a minute, just once I've written it down. We have the probability that A given not B is 11 over 20. What could we do next then? If we're trying to find out all the areas in here, we have this information. What have I suggested you do if you come across a question with a given probability in like that?
Work out A and B.
Sorry?
Work out A and B.
I want to work out the A and the B. How do I go about doing that though?
Times A and B together.
Not yet. What is it? Is the A? Yeah.
Is B given not A the bit where it's B and it's not A?
Unfortunately, it's not just that. No, that would be sort of B and not A. The given ones you can't just put in straight away. What formula have we done that looks something like this?
Is it when you do
B intersect not A.
like B and...
Just go back a bit. What sort of probability is this here? Conditional probability. So, if you see that, you should be thinking the formula for conditional probability. Okay, what is the formula for conditional probability? Yep.
The probability of A when it's intersection B over the probability of B.
Okay, that's the conditional probability formula. So you should be thinking of using that. So up here, what is this equal to? If you substitute those bits in here, what is B given not A equal to in a formula like this, some sort of fraction? What will it be?
1/3.
Well, just writing it down in this form. I don't want any numbers yet, just a notation.
Is it B intersection not A?
Yep.
Over not A?
Yeah. Okay. That's what it is, just rewriting that formula like this. Okay. Now, do we know any of these bits here so far?
Yeah.
Which bit do we know?
B and not A.
B and not A.
We know not A.
You don't.
Don't know that at the moment. We haven't got enough information for that at the moment. Go on, which one do you reckon we've got?
Probability of not being A.
Not A. Yeah, we know that A is 1/3, so not A is 1 minus 1/3. Okay, which is 2/3. And then we still don't know this bit at the top. So if I put some of these bits together, I know 11 over 20 equals the probability of B and not A over 2/3. Okay, just by substituting in. So I've written down my 11 over 20, that's here. That top bit is here, and I've already worked out the bottom bit of that fraction was 2/3. So what can I work out from here? I can work out this bit here, B and not A, by times those together. So that 2/3 times by the 11/20ths will give me the probability of B and not A. And if you do that, that comes out to be 11/30ths. So B and not A, it's in B and it's not in A, that is this bit here. So this bit here is 11 over 30. When you know that, because you know that B is 2/5, if you take that away from 2/5, so if you now do 2/5, take away 11 over 30, you will get what this bit here is, because you know altogether there's 2/5 in here. That works out to be 11 over 30. So you've got 12 over 30 there. That cancels down to be 2/5. You know, in the A circle, you've got 1/3. If you've got 1/10 over here, do you know what this one here will be? How can I work out what this bit here will be?
A third take away the 30th.
Yeah, a third take away a 30th. Okay. How can I work out that sum? If you're doing it on a calculator, you can type it in. 1/3 is the same as 10 30ths. Take away 1/30th. That's going to be 9 30ths. That's the same as 3/10. If you cancel that one down. So over there, I've got 3/10. Since I'm doing the Venn diagram, and that was a good idea, if I've got those three numbers, there should be another number outside somewhere. How can I find out the outside number? Now I've got those numbers. Yeah, add all of those up and take that away from 1. And if you do that, you get another 3/10. Now you've got the Venn diagram done. So whoever suggested the Venn diagram, that was an excellent idea. We've got the Venn diagram done. We have all our numbers. Now we should be able to answer the question fairly straightforward. So part A of the question was A intersection B. That's that bit there. So part A intersection B, the answer is 1/30th. Part B, A union B, that's those three added together. Another way of thinking about it is everything except that 3/10 down there. If you add those three together, you get 7/10. Part C was the probability of not A given B. Okay, we need to do a bit more work here for this one. I'm just going to move down the page. Part C was the probability of not A given B. Last time we met a given probability, we changed it into the fractional formula. Alice, can you rewrite that for me, please? That's a not line there into the fraction formula.
Not A, B
Yep.
over probability of B.
Yeah, that's right. Okay. So the probability of not A and B. Not A and B. Let's look at the Venn diagram. Up here, what is not in A and at the same time is in B?
11/30.
Yeah, it's that bit there. It's at 11/30ths. The probability of B, we've known all along, was 2/5. And if you do that divide, you'll get the answer of 11/12. The last bit of the question, part D, was A given B. So A given B is the probability of A and B over the probability of B. A and B we can read off as 1/30th. B, we said a minute ago, was 2/5. And if you do that dividing, you get 1/12. There are two more parts to this question. Part E, I call it part E, or part 1 as it was here, is are they independent? Are A and B independent? Can anybody tell me what is the condition for independence? How can we tell if they are independent? There's one condition you need to learn. What was it? Yeah.
A times B equals the intersection.
Yeah, so you're asking yourself, does the probability of A times the probability of B equal the probability of A and B? If it does, they are independent. Right, A was 1/3, B was 2/5. If you times those together, you're going to get 2/15. A and B was 1/30th. Is 1/30th the same as 2/15? No. So they are not independent. And the final one, part 2, was asking, are they mutually exclusive? What did mutually exclusive mean?
The Venn diagrams cross over.
Don't cross
The circles don't.
The circles don't cross over. I mean, mutually exclusive means they cannot happen at the same time. So, either you have to draw them where they don't cross, or this bit here would have to be 0 for them to be mutually exclusive. And that is not 0 there, so they are not mutually exclusive. Sorry, I'm just going to go back on that one.
Why were they not mutually exclusive? Sorry.
Okay. If they're mutually exclusive, they cannot happen together. They cannot happen together. Well, these can happen together because there is a probability of them happening together, so they are not mutually exclusive.